Welcome. In this video, I'm going to show you how to make a burst measurement programmatically using a LadyBug LB5900 series power sensor. This will work for any of the 5900 series sensors from the 8 gigahertz version up to the 50 gigahertz version. I'm going to use a Berkeley Nucleanoics Model 865 source. I'm going to use it to generate a pulse at 20 gigahertz, and that pulse is going to be representative of our burst in our signal. So here are the specifications. The signal is 20 gigahertz. The burst is 300 microseconds. There's an off time which I'll set, but it's irrelevant because we're going to trigger on the beginning of the burst and we're going to measure the burst. So these are the commands I'm going to send to the sensor. I'm going to use the LadyBug Interactive I/O to send these skippy commands to the sensor and read back the response. No other software is being used and no other calculations are being done. All the returns are coming directly from the sensor. So the first thing I'm going to do is I'm going to preset the sensor to a known condition to clear out anything else that might be in there. And then I'm going to set the frequency, and then I'm going to set the detector function to normal. And this is the video filter rate inside the sensor after the detector. And this is its faster mode, so it's got a 7 microsecond rise time in this particular mode. I am going to set the trigger source to internal because I'm using internal triggering, and I'm going to set the trigger level to -5. And then I'll set the sweep time, and this is the time between the gates, and it's going to be 250 microseconds. And I could push that out a little bit to get closer to the full 300 microsecond pulse, but for the purpose of this demonstration, I'm not going to do that. And now I'm going to set the sweep offset time, and this is nothing more than trigger delay. So when it allows for the rise time of the sensor to pass before you start making the measurements. So I'm going to set that to 10 microseconds. And then I'm going to set the sensor to use a calc feed function, which calculates the average power between the gates. It's going to return that to you, and that's again an RMS value. So regardless of your modulation bandwidth, if you put a 500 megahertz modulated signal in there, it's going to give you the true RMS value of that signal. And after that, I'm going to start issuing fetch commands to the sensor, and the fetch just waits for the trigger and returns the measurement. Okay, let's make the measurement. I've got the GUI for the source open, and I've got the interactive I/O for the sensor open, and we are going to set up the sensor first here. So the first thing I like to do with the interactive I/O is to send a start-in command. It's a query with a question mark after it, and these are all skippy commands. And during this little presentation, all of the processing is done inside the sensor. So our measurements return directly from the sensor. No processing is done in this software. And all of this can be done with other software. You can access the sensor programmatically. You can use a SPI cable with our direct connectivity option, or you can talk to it from C or however you like to program. We're programmatically friendly. So let's get started with our commands. First thing we'll do is we'll send a system preset default to return the sensor to a default condition. Then we'll set the frequency, which I've got it here in gigahertz. You could set it as 20,000 megahertz. Sensor doesn't really care. It takes either. We'll set the detector function to normal. Now this is the video filters after the detection diodes, and this sets them to I have about a 40 kilohertz video bandwidth, a 7 microsecond rise time, and again these are true RMS responding diode detectors, and regardless of your signal's modulation bandwidth, it's going to return the RMS value of that power level. So we're going to use internal triggering, so we'll set the trigger source to internal. And as you can see, I've been playing with external too. It makes no difference in reality. I just have it set this way. We'll set the trigger level to -5 dBm. This is dBm. Most of the settings are in dBm. And so now the sweep time, we want to 250 microseconds. Now we could send 275, or we could try to grab more of the burst, but I'm just going to grab the heart of it for this demonstration. I'm not going to worry about pushing my way to the edges. So now the sweep offset time, this is a trigger delay. So when the trigger is issued, the sensor is still, the rise time is not fully completed. So we want to delay our measurement just a little bit to account for that. So we'll put in 10 microseconds. We could push that down a little bit if we wanted to, but for the purposes of this demonstration, that's adequate. Now we're going to send calc feed command, and what this does is this tells the sensor to take everything between our gates, all those measurements between our gates, average them together, and return one to our MS value average power level on that. And so with that, the sensor is set and it is ready for this fetch command. But if we send it now, it's going to time out. And the reason is we don't have any power. We don't have the source enabled. So I have it set up here. We'll just take a quick look at it. I've got it set for 20 gigahertz and plus 10 dBm, which should be about the top of the pulse level. And let's look at the pulse, which I've got it set for, there's a little dot in here. So it's 0.3 milliseconds, which is 300 microseconds. And then I got a repetition time of 40 milliseconds, which is really irrelevant because we're triggering on the pulse. We don't really care what the off time is. So we're going to turn on the power and the modulation, and we'll send our fetch. And there is the average power during the burst. And you can just repeatedly send that. When you issue the command fetch, it waits for the trigger and makes the measurement, returns it to you. And so there you go. And you can change the settings and access this from a lot of different software, even Excel if you so choose. Hope you've enjoyed this video. Thanks for watching.